There you are. Thank you.
Okay, thank you.
Hello, good morning, and thank you for giving me an opportunity to talk about this project when a team of data engineers from different organizations having mostly bioinformatics background has been presented with a task to build a data processing platform for national studies of pollution and health. And as you can deduce from the name of the organization, it deals with the healthcare research. It uses a lot of different data sources, including climate data from Google Earth, pollution data, obviously, demographic data from census, and so on. But most important is health data, and health data is highly confidential, so it's not possible to share health data sets between different research groups, even if it's the same data set like Medicaid or Medicare data. So the only way to reproduce each other results is really to share workflows, and then groups can run shareable workflows in their own with their data available to them. And this is something that has been long recognized in the community of bioinformatics. And as I mentioned, we have mostly bioinformatic background. So we definitely wanted to leverage our knowledge. Granted, data engineering pipelines perform a little bit different tasks than bioinformatic pipelines. It's mostly data acquisition from various data sources, data cleansing, record deduplication, query optimization in databases, and so on. But surprisingly, portable workflows are really not common in the data engineering, at least not to my knowledge, which is really a problem for population health research. And there is no consensus between data engineers about what language should be used for describing workflows, even less agreement on whether it should be a text language, which again we recognize in bioinformatics. A little bit more in detail about the specific requirement we faced. First of all, the final result of the workflow should be a data warehouse optimized for fast queries, not a set of files or documents as common in other cases. The platform has to be easily installed without the help of IT professional. It should have a graphical user interface for execution control, and it should be able to operate in a secure environment behind a firewall that completely blocks both inbound and outbound direct internet access, which is a huge problem both during installation and executing tasks like data acquisition from external sources. It also should be able to run tools written in database languages, right, like PL, PG, SQL, because data cleansing often is best done within that database. So that's basically what we have built. We have selected a common workflow language, basically OWDL. We have selected suitable Airflow as a platform to execute it. And we built a Docker-based deployment using Docker Compose to orchestrate various components of this deployment. The runtime configuration is done using Python virtual environments and optionally Conda package management. Tools can be written in various languages, and the platform has production and development mode. It has been deployed for national studies of air pollution and health on Harvard University, a research computing cluster on CentOS using Puppet for infrastructure management, and also in Red Hat OpenShift cluster on IBM Cloud using Terraform as infrastructure management tool. The platform is operational and is used by researchers. However, we do face a few pain points. Restarting workflows from arbitrary task is not trivial. We do have some issues with prioritization and progress monitoring, and we have something on GitHub. Thank you.